Pat has already indicated he wishes to reply.
Yes.
Well, a wonderful discussion, Nancy, and the thing I would add here is something I should have done in my probabilistic causality. So we can take this comment as the fact that what I wrote was incomplete. And there is a further argument here, and you should have asked me to come along to argue with Rawlings and Chalmers.
That would show that.
If that one scared them, I didn't.
That further argument, though, is fairly straightforward. And that is what Nancy's saying, and talked about positive effect. Now, statisticians, of course, aren't going to be quite satisfied with that, and for good reason. And so what is really important, and I want to make a slightly extended comment here because it goes from education, what is really the second step is to quantify this. And in fact, on the U.S. Department of Education, that what the gold standard is for education, that the effect size is 0.8. Now, you might say, what does that mean? Well, it has a very clear meaning. The 0.8 is a measurement of standard deviations for the mean. So we normalize and have one standard deviation in the two distributions, the control of the experimental. And in education, it's considered extremely where the argument goes. See, it isn't enough quite. And this is, I'll blame myself rather than Nancy. If you have, say, an effect size of 0.005, let's say, and it always is positive, still it may not be worth the effort to have that kind of effect size. If you go to physics, for example, or even more, where there's a great slogan on this, at operations research in the engineering school, they have a great slogan. Some of you may have heard it. 6 sigmas. Harvey, what does 6 sigmas mean?
I learned it from the annual report of one of the stocks I hold.
What does it mean?
And all I know is that GE has been a disaster. So that's all
I like that. Harvey, we like to go back and forth. Love Harvey. 6 sigmas, of course, means 6 standard deviations.
Yes.
Now, almost never in education has anybody, or in medicine, had anything close to 6 standard deviations.
Right.
So that is really big time.
Yep.
No. So it depends on the discipline of what one expects. And of course, in physics, physicists they hate p-values. In physics, that's the way to talk, is in terms of standard deviations. They don't need any more talk. A physicist runs an experiment and says, yeah, this differs from the classic prediction by 3 sigmas. Very good result. And of course, what a statistician can also do with the full apparatus, if you want to attach a p-value, and there are criticisms of p-value. I won't go into criticisms of p-value here. To the effect size. So, for example, Nancy's exactly right on this reading of the Department of Education. You are really not permitted to publish results when you have simply a p-value. See, the standard example in statistics is something like chi-square. Then if you have even the smallest difference, you can produce a difference in the chi-square from the null hypothesis by sufficiently large sample. So it's got like an epsilon delta argument. I won't expand on it, but you can get at least a small difference, no matter how good and how close the two are, unless they're just absolutely the same, the two distributions, which is very uncommon. So it is important, and that's why in the Department of Education manual, they now want you to have a column showing effect size, which the physicists take as automatic, and it's only come to be realized. And in fact, in a lot of psychological publications, Nancy, they don't give effect sizes. So the one thing this is about is, I should have added, for real use, the discussion of effect size. And it's going, as we like to say, which I claimed I did not do in that, it's going from probability through statistics and the analysis of data in a sharp way to go on from positivity to effect size.
But there's something else to add about that.
I'm sure you want.
Yeah, one of the reasons that